So we have solved systems with substitution and elimination, but we can also solve them with matrices. This is one of the reasons we looked at matrices, and one of the reasons we looked at determinants and the other things that go along with them. So this is one application of that stuff. So here is a linear system, two equations, two variables. We have certain kinds of matrices that we can create from that. We've got the coefficient matrix where that would not be a good thing. You can't see that. Your coefficients are the numbers in front of the variables, all right? So I'm going to take these two here. So that's a 1 and a -5. And these two here, -7 and 2. Okay, so that is your coefficient matrix because I made it from the coefficients, right? A couple of other matrices we have to understand are our variable matrix, so x and y, because those are the two variables we're using. So this is our variable matrix. And then from this same system, using these two numbers, the 9 and the -30, that is our constant matrix. So we have some terminology handled there. Okay. So if I want you to see how this works. Let me scroll just a little bit here. If I take my coefficient matrix, which is 1, -5, -7, 2, and I multiply it by my variable matrix, x, y, okay, then that is going to equal my constant matrix, which is 9, -30. Okay. Now we're not actually going to multiply anything like this. I just want you to see how these all relate together. If we were going to multiply them, remember, because it's been a minute, that when you multiply the matrices, we would take this top row, the first row times the first column, you multiply them and add them together. So I'd get 1 times x plus -5 times y, that's that right there, and that equals 9. And then I would take -7 and 2, multiply it by this, so I get -7x plus 2y, and that would equal -30. And that's where that stuff is coming from. So that's kind of how they fit together. We're just kind of taking them apart so that we can do our Cramer's rule with it. Okay, it's Cramer's rule. It's named after a Swiss mathematician named Gabriel Cramer. Whether or not he was the first one to come up with it, who knows? The people that things get named after aren't always the originals, but that's who it's named after. But using our determinants. So we are also going to review what a determinant is because it's been a minute. First of all, we are going to take, so here are our two systems. So we got A, B, C, D, E, and F. This is our coefficient matrix, just taking the variables in front of, or the numbers in front of the variables A, B, C, D, that's where this is coming from. Then to remind you that this, which looks like the absolute value, is not what that means. That means it's the determinant. And then when we go through our first example, I'll remind you how easy it is to do a determinant of a 2x2. I'm looking for, when we solve a system, we're looking for an x and a y. Both of them use the determinant of the coefficient matrix. That's what we're dividing by. The numerators are determinants of other matrices that you come up with, which at first is going to seem weird and confusing, but I promise you when we do this, it's not that big of a deal. We are looking for, when we're looking for x, notice that the A and the C are what are multiplied by x. So like this is our x column, and this is our y column. If you look at your coefficient matrix, you replace your x column when you're looking for x by your constants, and then the BD, that's your y column. When you're looking for y, you leave the x column, you replace your y column with the constants. Okay, and I know it all seems a little bit more confusing when it's variables. When we do it a couple of times, you'll realize it's not that bad if you just hang on with me. okay? Because we only have 2 examples, and I think you'll get the hang of this pretty quickly. So we start off with finding, or making, rather, our coefficient matrix. That's coming from this system that we want to solve. So that first row is going to be 1 and -5. So my second row would be -7 and 2. Everybody okay with that? Coefficient matrix. Then we are going to find the determinant of the coefficient matrix. Here's how you do the determinants. Determinants of 2 by 2, way easier than any other 3 by 3 or anything else. It's down minus up. So I do this down diagonal. I do 1 times 2, which is 2, minus the up diagonal. And so that -7 times -5 is a positive 35. So I get a negative 33. Okay? So the determinant of the coefficient matrix is negative 33. That is what goes in the denominator of each one of these. Okay? Any questions about where anything came from so far? All right. So now we are going to look for x. And when we look for x, the denominator is negative. Sorry, let me make that a little bit lower. The denominator is a negative 33. The numerator, we are going to write the matrix, but look, because I'm looking for x, I replace the x column with the coefficient, with the constant. So this is 9 and negative 30. Try not to be in the way. And I leave the y's, which are -5 and 2. Do you understand where the numbers came from? My coefficient matrix, I'm looking for x. The x column, which is the first one, gets replaced by my constants. The y column stays the same. Everybody with me? I'll take that as a yes. All right, so then I'm going to find, the reason I didn't make the little brackets is because I want the determinant of those 4 little numbers. So now I'm going to multiply 9 times 2, that is 18, and I'm going to subtract -3 times -5, which is what? 15? Did I write a number down wrong? Oh, I'm sorry, that's not -3, that's -30. That makes more sense. Minus 150. What did I do wrong? Okay, ask me a question. That's a -7 and -5, right? Yes, yes. And you multiply those two? Yes. And this is down minus up. Are y'all okay? Wait, how do you get -35? Because it's minus 35. It's down minus up. So it is a positive 35. So thank you. It is a positive 35, but I'm subtracting it. Thank you for asking. Everybody good on everything else? Okay. I accidentally did say 3 here and not 30 because of my stupid little, you don't have to do the little crossword-like things. I'm just making sure you know where I'm going with that. Okay, good question. Everybody else okay? Thank you for asking. All right, so now 18 minus 150 is a negative what? 132 divided by a negative 33. And so that means that what you get here is x is equal to 4. And you'll be able to use your calculator, it's fine. I do want to say now, so I don't forget, in Delta Math, you are very likely to get fractions for these. I didn't make these fractions so that we didn't have to worry about reducing them. But remember, in your calculators, if you type this in and it's a decimal, just hit math enter. It's your best friend, and it'll give you the fraction back reduced if necessary. But I don't want you to think if you get weird fractions that you're doing something wrong. Okay, so now we're going to find y. So when I find y, I know I'm going to divide by a negative 33. I'm looking for y. So remember, this is your x column and your y column. When you're looking for y, your x column stays the same. Your y column gets changed to the constants over here, which is 9 and negative 30. So we're going to multiply down. So 1 times negative 30 is negative 30, minus up, which is a negative 63. So that becomes plus a positive, dividing by a negative 33. So this gives me 33 divided by a negative 33, and y is equal to negative 1. So your answer as an ordered pair then is 4, negative 1. Okay. So 3 different determinants that you're finding, and you divide them out. Everybody, any questions about where anything came from right now? Okay. So here's what I want you to do. We're going to do this piece at a time on your own. I'm not going to just turn you completely loose. But write your coefficient matrix. Write the coefficient matrix. Two, 6, 5, 1. We agree with that? Okay. So now define the determinant of A. Down minus up. Yes, it is down minus up. All right. So we get negative 28. Any questions about where any of that came from? All right. So now we're going to find x. I know I'm dividing that by negative 28. Write down the 4 numbers that go in the numerator, since we are looking for x. When you are looking for x, you replace the x column. Okay. Do you agree with what I wrote in the numerator? And understand where the numbers come from. You replace the x column with the coefficient column, leave the y column. These are, looks like the absolute value. That means I'm looking for the determinant. So that's down minus up. 38 minus a negative 18 over a negative 28. Careful with your signs there, because it is down minus up. $56 over negative 28. We okay with that one? All right, so that means that x is equal to negative 2. Now I want you to find y. Let me give you a minute to get started. Whole thing on your own. I'll work through it slowly so you can check yourself along the way, but I do not want you just writing down what I have. Ask me a question if you're confused. Double check yourself along the way. So especially if there's some funky numbers, this might be a way better option than substitution or elimination, right? If you know the patterns, it's not that bad. I would think, like, if you don't use it for a long time, probably substitution or elimination will come back to your brain quicker than this will, because you'll be like, what the heck do I do when? But again, this is something that you'll need for next semester. So any questions at all where anything came from? Okay, you've got this to follow along with. You can use your calculator. Just know that you might end up with some fractions and it's all good. Okay, any questions? All righty, make good use of your time.